Alright guys, Mr. Gucci here to help you with your Unit 10 review for the final exam. In this video, I'm going to work on problems 6, 7, and 8. But the first thing we need to do is balance this equation right here. We need to balance it in order to work on the following questions. And there will be questions like that on the final where you have to balance an equation as the first step in solving a greater problem. So let's get to it over here. So I've pasted it in. Let's get down to balancing. We've got 2 carbons over here and 1 over here, so I'm going to put a 2 in front. All right, done. There's 6 carbons over here and 6 hydrogens over here and 2 hydrogens over here, so I got to put a 3 in front. All right, now we've got 2 times 2 is 4 oxygens. 3 times 1 is 3 oxygens here. That's a total of 7 oxygens on this side. Now we have a problem because this is O2. So what do we have to multiply 2 by to get 7? Well, 3.5. 3.5 times 2 is 7. Now you might be like, Mr. Gucci, you can't have a decimal in there for a coefficient. And you're right. You're absolutely right. So what we have to do is double it all right? This was 1, now it becomes 2. This was 3.5, now it becomes 7. This was 2, it becomes 4. And this was 3, it becomes 6. So there you go. There is your balanced equation, all right? So on to the next question. Here we go. Question 6. If you had 8 moles of ethane, how many moles of oxygen would you need to react it completely? So 8 moles of ethane, how many moles of oxygen? So here we go. We're going to set this up, all right? Problem number 6. All right, you've got 8 moles of ethane. You might be like, Mr. Gucci, which one of these is ethane? Well, that's not ethane. That's oxygen. That's carbon dioxide. That's water. Ergo, process of elimination, ethane is C2H6. And we want to figure out how many moles of oxygen are we going to need. All right. Now, you might be thinking, oh, this is a 3-step problem. No. All right. This is actually much, much simpler because we don't have to convert our starting amount into moles because we're given moles. So that step is gone. All right. And we don't have to convert our final amount out of moles because it asks for moles as the final answer. So after balancing the equation, we only have one more step to go. We have to get out of C2H6. All right, we have to get out of ethane and we have to get into O2. And for that, we go to the balanced equation. 7 O2s for every 2 ethanes. So 8 times 7 halves. Here we go. 8 times 7 divided by 2. You get 28 moles of oxygen. All right, that was an easy one. That was just a mole to mole conversion. Students often get these wrong, however, because they're thinking every conversion has to be 3 steps. All right, like the next one. All right, question number 7. If you had 3 liters of oxygen, how many liters of carbon dioxide would you make in the above reaction? So I'm going to move this down a little bit. So you've got 3 liters of O2. All right, now we've got a problem here. We have liters, and so we have to get out of liters into moles of O2. All right, out of liters into moles of O2. So to do that, we divide by liters to get into moles. The relationship between liters of gas and moles at STP is 22.4 liters for every mole. So 3 liters of oxygen divided by 22.4 gets us 0.134 moles of oxygen. Okay? So we've got that number right there. That's how many moles of oxygen we have. Now we have to figure out if we have 0.134 moles of O2, how many moles of CO2 is that going to produce? So out of O2 into CO2, and we go to the balanced equation. All right, O2 is 7, CO2 is 4. So 0.134 times 4 over 7, and we get 0.0765 moles of carbon dioxide. So now on to the last step. We have got 0.0765 moles of CO2, and we want to figure out, well, how many liters of the CO2 is that going to be? Okay, well, get out of moles and into liters. 1 mole is 22.4 liters. So this number times 22.4 is 1.71 liters of carbon dioxide. And this seems right. This seems about right, okay? Very good. So, on to the last problem for this video. If you had 65 grams of ethane, how many grams of water would you make in this reaction? So, we have got 65 grams of ethane, and we want to know how many grams of water would we produce. Well, first step is we got to take our grams of ethane and get it into moles of ethane. All right, so we have got to get out of grams and into moles. Now, unfortunately, unlike liters, which is always 22.4, to figure out grams into moles, we have to actually figure out what is the molar mass of ethane. C2H6. I'll do some rough calculations over here. Let's see here. Carbon is 12.01, so 12.01 grams per mole times 2, plus 6 hydrogens, which is 1.008. So altogether, the molar mass of C2H6 is 2 times 12.01 plus 6 times. So the molar mass of ethane is 30.07. So 65 divided by 30.07, this is about 2.16 moles of ethane, okay? So now we know how many moles of ethane there are. We're going to plug this in. All right, we're going to plug this in. 2.16 moles of ethane. And we want to know how many moles of water are we going to produce. So we have to get out of ethane, C2H6, and into water. And then we go look at the mole ratios from the balanced equation. Let's see here. Ethane is 2 from the balanced equation. All right. And water is 6. So there we go. 2.16 times 6 divided by 2. So we have got 6.485 moles of H2O. All right, last step here. We're going to take our 6.485 moles of H2O, and what the question asked for was how many grams of H2O that is. So out of moles into grams. 1 mole of H2O is how many grams? Well, I'm going to skip to the final conclusion here. H plus O is essentially 1 plus 1 plus 16, so that's 18.02 grams per mole. So altogether, we produce 116.9 grams of water. All right. You might be like, but we only had 65 grams of ethane. How did we get even more water? Well, because we consumed a lot of oxygen, and that adds to the weight. So there you have it. Okay. That is this video, guys. I hope this helped. Thank you very much.